Hello, and welcome to this short video presentation, How to Unclog a Flow Cytometer, Part 1, presented by the International Society for the Advancement of Cytometry and CytoU. In this short multimedia presentation, a systematic breakdown of the common steps towards unclogging a flow cytometer will be described. Although the specific examples given may not apply to all instruments, the methodologies described should apply to any flow cytometer. Always consult with your instrument's manufacturer for guidance and do not attempt any procedure which may void your service contract or warranty. My name is Jellison, Director of Flow Cytometry at the University of Connecticut School of Medicine, and I'll be your narrator for today's presentation. In this presentation, I will discuss common troubleshooting techniques used to identify and eliminate clogs in a flow cytometer, starting with the simplest and least invasive methods, and moving towards more complex and more interventional methods. May we never forget Shapiro's first law of cytometry. A 51 micron particle clogs a 50 micron orifice. Part 1. Basic Troubleshooting. To begin, the first thing to ask when presented with a loss of events on screen is, do I have a clog, or is there some other problem with the instrument? The easiest solutions are sometimes the right solutions. On the other hand, if you can see particulates or debris in your samples, you likely clog the cytometer. But first, let's check the sheath fluid level to be sure there is enough. Next, let's be sure no air bubbles have airlocked the sheath filter. Trapped air can typically be vented through a valve on the sheath filter. Carefully unscrew the vent cap or roller valve until only liquid escapes. If your instrument is equipped with a hydrophobic filter on the waste cap, check that as well to be sure it isn't wet. Back pressure can sometimes mimic clogs. You'll want to be sure that the system has pressure, or that the fluidics pump system is functioning properly. For air pressure-driven systems, check the pressure gauge, or otherwise listen for an audible hiss when pressure is released. For systems relying on a wet cart or fluidics pump, be sure the last user reset the system after refilling the sheath fluid. Next, we want to verify that the cytometer's workstation has not physically or electronically lost connectivity with the cytometer. On some systems, connectivity can be confirmed by acquiring during a prime cycle. If you can see air bubble events appear, the cytometer is connected, and there may in fact be a clog. Verify that all lasers are on and that the delays are accurate. For open systems, this can be checked visually. Always remember to follow proper laser safety procedures. On other systems, there may be software-based indicators, such as the two examples shown here. For multi-laser systems, consider triggering off of other lasers besides the primary laser in order to determine functionality. For cell sorters with automatic drop delay beads can be used to determine if sample is making it past the flow cell and into the sort chamber. Run the drop delay beads as a sample and engage the optical filter for drop delay. If you cannot see events on the plots, but the stream camera can see the beads, there isn't a clog. If no beads can be detected, either on the screen or by the side stream camera, there may be a clog, and you should proceed with further steps outlined in this presentation. As with any assay, reproducibility is key. This too is true for procedures as unglamorous as clog removal. To this end, it is important to verify that the instrument has not changed in any way as a result of your intervention. Ideally, you can rerun a sample that was successfully run before the clog occurred, but in the absence of such a sample, control cells such as glutaraldehyde-fixed chicken red blood cells, leftover compensation control samples, or even quality control beads can be used to verify the instrument's performance. In a pinch, you might elect to run an aliquot of a new sample to verify that the clog has indeed been removed and your instrument is performing as expected. We have reached the end of this presentation. Thank you for tuning in. Be sure to check out parts 2 and 3. And for more great cytometry-related educational content, please visit us on the web at cytou.org. On behalf of the International Society for the Advancement of Cytometry, thanks for joining us.